All right, guys. Shh. Let's talk about this. All right. So, yesterday we talked about open boxes. So, this warm up came from, it was that last problem on page 3 that we didn't do yesterday. So, first off, who remembers what the general formula for an open box is? It's y equals what? So, it's something 2x. Really, Aiden? Just put them on that table over there. So, shh. So it's x times L minus 2x times W minus 2x. So all you gotta do is just take the original width and length, plug them in, you got the formula. So that being said, letter A, that's what you have to do for the first one. So what is the formula? Y equals what? Good. You just take the 22 and the 28, plug them in for length and width. Now, remember what I said. After that, it goes into Desmos. So in Desmos, you type it in, you got x times 22 minus 2x times 28 minus 2x. And you may have to zoom out some to see it. Sometimes changing the window also helps. So let's do. All right, so here's what the graph kind of looks like. So if we draw the graph, it looks something like this. Now, letter C asks, what is the largest square that you could cut out of the corner? So remember, when we talked about these squares the other day, when we made our open boxes in the activity, what part of this graph told us where the largest volume was and where the largest part of the square was? So what part of this graph told us where that max volume was? The very peak. So right here. So if I go back to Desmos, it should already graph that point for you. So round to the nearest 100, that's 4.08 and 1120.31. So that's 4.08, 1120.31. Which value is the size of your square? The x or the y? The x. So that means this would be a 4.08 inch by 4.08 inch square. That's the size you would cut out of each corner. What would be, and that goes into C, what would be the max volume that you can make? Right, 1,120.31 inches cubed. Now, we then talked about appropriate domain and range. So remember, the domains, you want to look at the x-intercepts because those will help you figure it out. So if I go back to the x-intercepts, I got one at 0, 11, and 14. So 0, 0, 11, 0, and 14, 0. Now, between which two x values did I tell you is typically where we want volume to be? So our volume has to be what? Positive or negative? It has to be positive. Where's the only part of this graph in this view that there's positive between what two x values? 0 and 11. So here to here. And remember, since it doesn't actually hit 0 and 11 because we can't have 0 volume, we use parentheses. Now the range. Where's our range? So range is the actual volume. So where is it? What's the lowest volume that we can have? 0. So it has to start down here. Where does it stop? Right, our max volume. So it's really right here where our domain and range both lie. Now, we still use a parenthesis for 0 because we can't have 0 volume, but the upper barrier of the range, we can put a bracket on because it's actually defined there. Any questions on number 3? That was in the graph from yesterday. All right, so before we get into the new stuff today, I want to talk about one more thing with 7.1 that I didn't yesterday. So look at the next page in your packet. So it's kind of more the same. Find the number of corners of the size of the square, but we also want to figure out what would be the dimensions for the volumes, for specific volumes. All right, so not just the max volume, for specific volumes. And I'm going to show you how to do that. So first off, we need to write an expression to describe a paper size, which is 20 centimeters by 30 centimeters. So what would be the formula for that? X times, good. So this would be what we put into Desmos. So if I go ahead and put that into Desmos, I really just have to change the two numbers that are already in there. All right. Draw a picture of my graph. Still looks pretty close to the same. Now, our max volume is definitely not 864. But they want to know what the dimensions would be when it's at 864. So, remember, volume is represented by what value on the graph, X or Y? Y. So we're going to type into Desmos as well as Y equals 864 and find the points of intersection. So Y equals 864, and we have 3 different points of intersection, here, here, and here. So we have 2.13, we have 6, and we have 16.87. So this is 2.13. This is 6. This is 16.87. And this is when Y is equal to 864. And that's literally the possibilities for the heights of our squares. So the possibilities are 2.13, 6, or 16.87 centimeters each. Now, on the other hand, we have 1728. So we're going to do the same thing. We're going to type into Desmos Y equals 1728 and check the point of intersection. Now, This one is all the way up here above the graph at 18. So I actually need to expand this line a little bit more. So this one is all the way up here at 18. Now, why do you think that part A has 3 solutions, but part B only has 1? Look at the position of the 2 lines and what we know about the maximum volumes. Right, because 1728 is actually greater than the max volume, which means it probably isn't possible to get. So it's because 1728 is greater than the max volume. Now, they then want us to determine the dimensions of the box from the previous problems. So for part A, again, it was 2.13 for X, 6, and 16.87. For B, it was 18. How would I find the other 2 dimensions when I do length times width times height? What's something that I already found that can help me find those dimensions? The formula. All right. So the formula itself. So in other words, for this part of the box, we would do 20 minus 2x and take our x, put it in for x for 20 minus 2x. For this part, it'll be 30 minus 2x. And we plug in for x. So let's say I plug in 2.13 for 20 minus 2x. So 20 minus 2 times 2.13, it's about 15.74. So that's 15.74. If I plug in 6 into 20 times 2x, just erase the 2.13, replace it with 6, we get 8. If I put in 16.87, we get negative 13.74. And then if I put in 18, we get negative 16. If I do the same thing, but replace the 20 with 30, so that's the other dimension. I'm going to change this to be 30. So I have 2 times 2.13, that's 25.74. Two times 6, 18. Two times 16.87, negative 3.74. And then 18. So if it ever asks you the question, what's the other dimensions? That's what you do. You take the 2 pieces of the formula, like what's in the 2 other sets of parentheses besides the x, plug it in for x. Yes, ma'am. Just go ahead. All right. Now, looking at these dimensions, what's kind of off about some of these? Some of them are negative, specifically right here. Can we have negative dimensions? No. So if we have some negative dimensions, what do you think that means about those solutions? Can we have negative dimensions? No. So that means that those solutions are invalid. Because remember, we're talking about volume, meaning you have to have a real length, a real width, and a real height. But if they're negative, they essentially don't exist. So the only valid solutions are these two right here. And again, I just wanted to bring that one up because you may get asked a question like that on your test. Any questions on that? All right, so here's what we're going to do next. The next topic that we're going to be talking about is cross sections. So we're going to do an activity with that first. So what I need you guys to do is take out your Chromebooks if you haven't already. Go to my Canvas page and go to announcements. Yes. Here you go. It's right there. All the way. So if you go to announcements in Canvas, what you're going to click on, so look up here, what you're going to click on is the one that's labeled today's date GeoGebra activity link. When you click on this link, it should lead you to a page. It may ask you to log in. You can log in or continue as guest. I don't really care as long as you put your name on it. You also still need your packets. And I believe this activity is on page 9 of your packet. So it should be page 9 of your packet. You should see this. So I'll give you guys a couple of minutes to get into GeoGebra. Go to your announcements in Canvas. It's in the announcements. Don't do anything yet. I'll explain. Announcements.
Can I get my charger for me? She's right down there. Quickly. Thank you. Unless I'm not anymore.
No, you're not. You can go in. Sure. I'm not going to be sitting there. I'll be walking around.